Okay, in this video I'm going to go over sections 4.3 and 4.4 from the textbook. This is all about right triangle trigonometry and the trigonometry functions of any angle. So I'll do a bunch of examples and hopefully this will help with the homework. So let's suppose that sine of theta is unknown, is 3 over 4, but we do know that theta is in the first quadrant. So if we know the sine of an angle, right, the ratio 3 to 4, we know that we actually know that two sides of a triangle that this acute angle theta represents. So since theta is in the first quadrant, right, I can draw this triangle, right? The hypotenuse is the terminal side of that angle, and since I know 3 is the opposite side, and the hypotenuse would be 4, then the other side, which I'll denote by x, right, that's something else, and we can find that from the Pythagorean theorem. So let me real quick just find what that is. So 4 squared would equal x squared plus 3 squared. All right, subtract 9, we get 7 equals x squared. So the square root of 7 is the remaining side. Now that we have the triangle, which we know is in the first quadrant, we can find the other 5 trig functions of this angle. So we'll start with sine of theta. We know that was 3/4. And its counterpart, right, cosecant of theta, we know that would be 4/3. Cosine of theta then would be root 7 over 4, which means the secant of theta is 4 over root 7. Tangent of theta is opposite over adjacent, so that's 3 over root 7. So we know cotangent of theta is equal to root 7 over 3. All right, so this is how given two sides of a triangle, you should be able to find the third, right? And then that allows you to find all 5 other trig functions of that same angle. Likewise, here's another example. Say we know that secant of theta is equal to 6. And again, theta is in the first quadrant. So this one's a little bit more tricky, right? But we know that if secant of theta is 6, then what's cosine of theta? Well, what's the reciprocal of that? So I'll work with 1/6 here, since I know that cosine is adjacent over hypotenuse. I'll draw my triangle again like this. It doesn't really have to be to scale, but I know that the adjacent side is 1 and the hypotenuse side is 6. Let's call the other side y because it's vertical. Then 6 squared must equal 1 squared plus y squared. So 36 is equal to 1 plus y squared. So 35 is equal to y squared. So y is the square root of 35. Now that we have the other side, again, this is the angle theta that we're not sure what it is. We just know two sides of a triangle. I can find the other things. So let's, over here, I'll write sine of theta then would be the square root of 35 over 6, which makes cosecant of theta equal to 6 over root 35. Tangent of theta is the square root of 35 over 1, which makes cotangent of theta 1 over the square root of 35. So again, same type of problem. Here I was given secant, so I might as well switch it over to cosine because we're used to working with cosine. Here's another types of problems that we can encounter. So we have a 60-degree angle here, and we want to know what y is, which is the opposite side of this angle 60. There's 2 ways you can do this. You can do it kind of directly, since I don't know the opposite side, but I do know the hypotenuse and I do know the angle. I could say, okay, sine of 60 degrees must be equal to y over 18. And now 60 degrees is one of those perfect triangles, right? The prototype triangles. So if I draw the prototype, this is again not drawn the scale, but if this is 60 degrees, I know that the sides of this thing look like this. So this is these are similar triangles, right? If this one's 18, then we know that this must be 9, and likewise this must be 9 root 3. So I'll actually show you that. So what is sine of 60 using this triangle? I know that sine of 60 is root 3 over 2, and that must equal y over 18. Solving for y by multiplying by 18, we get that 18, y is equal to 18 times the square root of 3 over 2. So y is equal to 9 root 3. Okay, so the other way to do it is just, I kind of did it in passing here, right? Remember your prototype triangle, correct? Since the hypotenuse here is 18, the prototype has 2, right? I know that the adjacent side has to be exactly half of that. And what's the other side have to be? Well, compare these two. This one's just root 3 times 1. So if this is 9, it has to be 9 times root 3. Likewise, for this one, if I think of the prototype triangle for 45 degrees, I know that the two sides are equal, root 2, and 2. Right? So one thing, since we know the opposite and we don't know the hypotenuse, again, I would use sine. So sine of 45 degrees is equal to 20 over r. So sine of 45 is root 2 over 2. So now I would solve for r. To solve for r, I'd multiply on the other side. And then to get rid of, to solve for r here, I would multiply by the reciprocal of this. So I'm going to multiply both sides by 2 over root 2. So 2 over root 2 is actually just root 2. So my answer is 20 square root of 2. Okay? So those are just little equations you can figure up to solve for the unknown side. Another way to find to use trigonometry of any angle is to first, let's try to sketch out what's called the reference triangle. So here, if I'm given the angle 11 pi over 3, I can write that as a mixed fraction. So 11 over 3 is the same as, let's see, 3 2/3. So this is the same as 3 2/3 pi. So where exactly on the xy axis is that? Well, this means I have to go 3 pi and then plus another 2/3 pi. So 3 pi, right, that would be, right there is 2 pi. 1 revolution is 2 pi. So 3 pi will get me back here. And now I have to go another 2/3 pi. So that's bigger than 1/2. So I must be in the 4th quadrant. Okay, so this is the angle 11 pi over 3. Now, 11 pi over 3 is just how much more away, right, from another full revolution. Well, if I would have gone another pi over 3, I would have gotten 4 pi. So the reference angle, right, would be pi over 3. So this thing is what we typically call theta prime, the reference angle, right? And because that's pi over 3, I actually know 3 sides of this triangle, right? That's the 60-degree triangle. So I know that this is negative root 3, 2, and positive 1. Why is it negative root 3? Well, it's in the 4th quadrant, so the y-coordinate has to be negative. So that would be the reference triangle right there. Let's do it for a negative angle. So I have the angle negative 11 pi over 8. If I go clockwise, right, this would be negative pi over 2. This is negative pi, this is negative 3 pi over 2. So let's think about negative 11 pi over 8. That's the same as negative 1 3/8, right, pi. So this is negative 1 pi. So I have to go another 3/8 pi, right? 3/8 is just under a half. So this thing must be in the 2nd quadrant. So if I draw my reference triangle, correct, what would be the angle that's remaining inside here? Well, that's exactly that 3/8. So the reference angle would be 3/8 pi. And this is a weird angle, right? It's not one that we know. So here the reference angle is 3/8 pi, but I'm not sure what these sides are because they don't really fall in the unit circle. Okay, but that is still the reference triangle. So now we can use this idea of the reference triangle to actually compute, right, tangent or sine or cosine or of any angle that I want. So let's look at tangent of 10 pi over 3. So again, where does 10 pi over 3 lie? So let's first look at 10 pi over 3. Written as a mixed fraction, this would be 3 1/3 pi. So again, I have to go, positive angle, so I'd have to go counterclockwise. There's 2 pi, and then here's 3 pi. Then here's an extra 1/3 pi. So I'm in the 3rd quadrant. Okay, so what I have to do is figure out the angle inside here. Well, if this from here to here was 3 pi, then the rest would be exactly pi over 3. So this tells me that this is the 60-degree triangle. So this would be negative root 3, 2, and negative 1. And so tangent of 10 pi over 3 would equal negative root 3 over negative 1, which is exactly positive root 3. Okay, likewise, let's do one with degrees. So if I have negative degrees, I have to go clockwise. So here's 0, here's negative 90 degrees, here's negative 180 degrees. And I don't have to go any further because I'm only looking at negative 150. So if I start here, I would land in the third quadrant again, and my reference angle would be exactly 30 degrees more. So the 30-degree triangle has negative 1 here, 2 on the hypotenuse like always, and negative root 3 over here. So secant of negative 150 degrees then, and we have to remember what secant is. That's the opposite or the reciprocal of cosine. So cosine of negative 150 degrees would be adjacent over hypotenuse. So it would be the hypotenuse, which is 2, over the adjacent side, which is negative root 3. Now we can actually use this argument to work backwards. So let's say that we know that secant of theta is 2 over root 3. Well, that means cosine of theta is equal to root 3 over 2. So I could ask you a question such as this, right? What is the angle theta that gives me root 3 over 2? And only pick the solutions, because there's an infinite number of solutions, right? Only pick the solutions theta that are within 1 revolution. So the first thing you can think is, okay, where is cosine positive? Well, since cosine is root 3 over 2, right, this number is greater than 0. So I know that theta has to be in either the first quadrant, or it could be this angle right down here that lands me in the fourth quadrant, because I know that those two quadrants is where cosine is positive. Now, since I know cosine is root 3 over 2, that tells me the adjacent side is root 3, and the hypotenuse is 2. So here in the blue triangle, this must be root 3, and this must be 2. On the red triangle, right, this again must be root 3, this must be 2. Now, we notice that this is the other side using the Pythagorean Theorem must be 1, and this one it must be negative 1. So what angle, right, gives me the 1, 2, root 3 triangle? That's pi over 6. That's 30 degree. So this angle right here must be pi over 6, which means my reference angle here is pi over 6. And so if my reference angle is pi over 6 here, how much would be in the red angle? Well, that would be exactly 2 pi minus pi over 6, which gives me 11 pi over 6. So that's the red angle, and the blue one is the easier one. It's just pi over 6. Okay, so that's how you might work backwards to find the angle that we're talking about.